Valvik Ganbarte with your mentor Abhilash Sarkar. In this episode, we'll explain some of the proof property, or you can say it's not a direct rule; it is a derived rule that is also parallelly can be used wherever it is necessary. That is dependent on the inverse and the determinant. Okay, so these are some rules as we have learned some rules. For transpose of a matrix. Similarly, for inverse also there are rules that I have explained, that I have shown you in the last video. That was that if I take inverse of a matrix and consecutively do the inverse, that means inverse twice of the matrix. Once I do the inverse, then I again taking the inverse of the inverse, then I will get back to the original matrix. That is similar to, if you remember, for transpose also we have same formula. Transpose of transpose will give you the same. So, and another one is also similar to a transpose. If I take product of two matrix and I take the inverse, it will become the inverse of the second multiplied the inverse of the first in the same order as we did for transpose. There also the order of transpose has to kept inverse. So that means kept changed, because there is A into B, there B into a transpose. This has to be similar. So, and third one is yes, when transpose and inverse are done simultaneously. So if this has to be done somewhere, so this can also be a flexibility to do transpose first and then inverse. So inverse first, then transpose, and transpose first the inverse will give you the same result. So these are the three byproduct or by rule you can say, or the derived property. So let us understand or prove it with some examples. So in this case, for the simplicity, I will take 2 into 2 order. So for all this, the condition is that it has to be a square matrix, definitely 2 non-singular. These are the condition is all for this, except wherever there is a multiplication is coming, the matrix is of anything, rectangular matrix. But wherever this inverse, transpose, everything is coming unit matrix, where it must be a square matrix and a non-singular matrix. These are very fixed conditions. So A I am taking, let's say 2 3 3 2. Okay, so now to get A inverse, first we have to find the cofactor. Let's say cofactor of matrix, say cofactor matrix. If I say what would be the, because taking 2 into 2 order, it will be very easy to find the easiest way, but the rule are same for every matrix. So I am taking for saving the time or making you understand. Okay, so with the coefficient of 2 element is 2 only, because there is no other minor is available. So this is the only, so this I am taking 2. For 2 it will be 2, for 3 it will be 3, for this 3 it will be 3 here, and for this 2 will be 2 here. So only the position has changed, but this meaning does not mean it will be same. You have to find it the value. So now the cofactor, the sign will be assigned to plus minus minus plus, this way, because alternatively this is moving. If it is 2 terms, up to this it will be there, this will not be there. Here also next this will come like this. Okay, so the position sign you have to take care. Now what is the transpose of the cofactor matrix? Only thing 2, this will come here, but there will not be any change in the physical appearance of the matrix. This will be, this is already changed. Now what we have to do, this is adjoint of A matrix. This is this one. So what I need to calculate A inverse is adjoint of A and what I need more another thing that I need is the determinant of A. So determinant of A is for 2 into 2 order, this cross this minus this cross this, so 4 minus 9, that is equal to minus 5. So what you have to find by determinant? So this will be the formula. So now put this value A in, this is 1 by, this is 1 by determinant, and adjoint is a matrix, that can keep like that. So this is minus 1 by 5, because this value is minus 5, so this 1 upon this is minus 5. Adjoint I have taken this 2 minus 3 minus 3 2. So now adjust this inside, this will become 2 by 5, this will be 3 by 5, this will be 3 by 5, this will be minus 2 by 5. Okay, because minus is adjusted there. So ultimately what do you find? A inverse is a value that I will put here. Ultimately I will rub all this, because next part I need this part of the board. So A inverse become, I will keep it little up there. So this will be minus 2 by 5, minus 2 by 5, 3 by 5, 3 by 5 again, and here minus 2 by 5. Okay, now we have to work on this matrix. This you can assume to be another matrix B. Now to find A inverse of inverse, that means you are finding B inverse actually. Okay, so now we will do the same thing with B. So what you have found? Cofactor of B, that is equal to same one. For this it will be this minus 2 by 5, for this will be this 3 by 5, and this will be 3 by 5, this will be minus 2 by 5. Now we have to assign signature plus minus minus plus, so this all will be negative. Now you have to take transpose. So what would change? Only thing is that no physical appearance will change, only you know where you are putting your values. So this will become the same. Okay, now what else you have to find? Determinant of B. So determinant of B, this means you have to find this. So minus 2 by 5 into this 2 by 5 minus 3 by 5 into 3 by 5. This will be your case. So minus minus plus 4 by 25 minus 9 by 25. So this will become minus 5 by 25. This is equal to minus 1 by 5. So determinant of B is equal to minus 1 by 5. Remove this. I will use this part of the board. Determinant is. So what about B inverse? B inverse is adjoint of B divided by determinant of B. So this is equal to determinant of, you can see like that, and adjoint of B, you know what is there, minus 2 by 5 minus minus 3 by 5 minus 3 by 5 minus 2 by 5. Understood? Now B is equal to what? Determinant of B was, I have calculated minus 1 by 5. Now put this value minus 1 by 5 here, and the remaining this will be minus 2 by 5 minus 3 by 5 minus 3 by 5 minus 2 by 5. Okay, so this will turn up. So this is equal to 5 minus, and now you see if I adjust this scalar, this is minus 5 inside, so outside there will be nothing. The adjustment would be, if I multiply 5, this will anyhow become minus 5 outside, 1 upon 1 by 5, that is equal to 5. So now we multiply this, minus minus plus 5 will cancel, it will remain as 2. Here will 3 will remain, there 3 will remain, there 2 will remain. Now you see, this is what? This is exactly the matrix we have taken, and what we are calculating? B inverse. So B inverse is what? A inverse of inverse, because B we have taken as A inverse, so we are taking B inverse, replacing B, A inverse of inverse, that is equal to A. That can be proved. Okay. So we'll do with the same matrix. the other derivation. Let us see what we can find. So this is your matrix. Okay, I will see this as my matrix for the second example. Now what we have to, another matrix we have to assume. The second matrix could be taken as just similar 2 1 1 2 and 2 1. Let me take this. Okay, now we have to find first A into B. So to get A into B, what is the rule? You know, row into column, row into column. For first element, 2 into 1, that is equal to 2, 3 into 2, that is equal to 2 plus 6, so that is will be 8 here. Okay, now 2 into 2 4, 3 into 1 3, that means 7. Now next this 3 into 1 3, 2 into 2, that will be 7 here, 3 into 2 6, 2 into 1, that will be 8 here. So this is my AB. So now to find AB inverse, so first let me take this is equal to another matrix C. Now to find what, first the this is C. To get C inverse, I have to find C inverse. We have to find adjoint of C by determinant of C. This will be my rule. So adjoint of C, that means cofactor of C I have to find. So cofactor of C, that means for this it will be 8 7 7 8. This will be the same. So cofactor of C transpose, if I take, this will be nothing but 8 7. Physically there will not be any change. So adjoint, and sorry, there I have to take the sign. Cofactor is this, plus minus minus plus. So this will change. So this will be minus minus. So this will be the transpose. Now this transpose is adjoint of C. So and C determinant will be 8 into 8 64 minus 49. So this will be how much? 1 that will be 50 15. Okay, this will be 15. So if I take it 1 by 15 here, because one C determinant and the adjust and your matrix is minus 7 and 8. Okay, now if I adjust this will become 15 in the denominator of every term. So this is your C ultimate form of AB inverse. So this C inverse, that means I have found AB inverse. So remember this value, I'll put it somewhere here. I'm putting somewhere here. So what I find, AB inverse whole inverse is equal to 8 by 15 minus 7 by 15 minus 7 by 15 and 8 by 15 is my answer. Okay, so now the right hand side was individually this one. So if I want to get B inverse, if I want to calculate this side and A inverse, so B inverse, this means adjoint of B. So that means CB, that means coefficient vector of B will be 1 2 2 1 plus minus minus plus. CB transpose is equal to 1 minus 2 minus 2 1, and the determinant of B is equal to 1 minus 4, that is equal to minus 3. Apply this to this, so B inverse will become minus 2 will be adjusted inside, minus 1 by 3 2 by 3 2 by 3 minus 1 by 3. This will be my B inverse. Now similarly, if I want to find this part of this, so C of A is equal to the same 2 3 3 2 plus minus minus plus. C A transpose is equal to 2 minus 3 2, and determinant of C, sorry, determinant of A is equal to 3 2 to the 4 minus 9 minus 5. So then A inverse is equal to 1 by 5 will be adjusted there. So this will be minus 2 by 5, 3 by 5, 3 by 5 and minus 2 by 5. This will be the case. Now we have to multiply these two. So B inverse into A inverse. Okay, so what is that? B inverse means this one, minus minus 1 by 3 minus 2 by 5, that is equal to 2 by 15. Okay, 2 by 15. And now then this sorry let me write it somewhere so that orientation is okay. Now I will only work with this. Now I don't need this one because I have already calculated. So I need B inverse into A inverse. So B inverse is, I will write the matrix here, minus 1 by 3, 2 by 3, 2 by 3 minus 1 by 3 into minus 2 by 5, 3 by 5, this is 3 by 5 minus 2 by 5. Now you multiply this. So this into this is become this into this is equal to 2 by 15 plus, and then this into this 6 by 15. 2 by 15, 6 by 15 is equal to 8 by 15. This into this, that means equal to minus 3 by 15, and this into this minus 4 by 15, minus 3 minus 4, there is going to be minus 7 by 15. Okay, now this into this minus 4 by 15 plus minus 3 by 15, so minus 7 by 15, and this is equal to 2 by 3, 3 by 6 by 15, and this is equal to minus minus plus 2 by 15, 6 plus 2, that is equal to 8 by 15. Okay, so the ultimate answer that you will find by this is equal to this. Now you can match it, this and this, you will get the same answer. Hence you can say is this is equal to A inverse. That is true. Okay, so the second one also true. Now coming to the next, that is the third one. So for that also I will take the same example for 3. Let me take the matrix is 2 3 3 2. Okay, now A inverse, what we have to do, cofactor of A is equal to 2 3 3 2. Only thing is that it will become minus CA transpose, that is equal to 2 minus 3 minus 3 2 and your determinant of A is equal to 4 minus 9, that is equal to minus 5. Now A inverse is what, where 1 by minus 5, you have to calculate with this matrix. So now this remains, minus will be adjusted inside, 2 by 5, this is minus, 3 by 5 will be positive, then 3 by 5, and this is minus 2 by 5. So this is the ultimate A inverse. Okay, fine. So leave it this as it is. So now we have to take the transpose of that. So this we can assume to be B. So B transpose, that is, this means transpose is equal to how? So transpose is minus 2 by 5, 3 by 5, 3 by 5 and minus 2 by 5. So now you see this is the value, this I find by A inverse transpose. Okay, now remember this is my ultimate value for the left hand side. Okay, so now we will do the other part, that is the right hand side. Right hand side, what what is my first operation? A transpose. So I will get the A transpose first. So A transpose is equal to 2 3 3 2. Now ultimately you can see by from this, exactly from this example you can understand, as A and A transpose does not change for this case, that definitely answer will come or you need to calculate. But whereas if it is a different kind of matrix where it is going beyond 2 by 2 or 2 by 2, then definitely you cannot say this A transpose A is equal. So there some hurdle may come, but if you concentrate enough you will able to solve it for that, for this reason. Now from this similarity you can say as A is equal to A transpose, so definitely A transpose A transpose whole inverse will be the same value. So let me also let me do it for yourself. So this is transpose is this one. So now what I have to find? I have to find the inverse of that. Let it be any other matrix D, assuming. So D inverse I have to find right now. So for D inverse I have to find the coefficient of D, means cofactor of D, that is equal to same 2 3 3 2, but only thing minus will come. So now CD transpose is equal to 2 minus 3 2, and determinant of D is equal to minus 5 again. Okay, so now D inverse is equal to adjoint, so minus 1 by 5, and the matrix is this one 2 minus 3 2. So now if we adjust this minus 5 inside, you will get the answer minus, this will be plus, minus plus, this will be minus. So now D inverse, that means it is D is A transpose whole inverse, and here A inverse whole transpose, the value are same. So this also can be say true. Okay, so need not to worry. If you can see it for 3 cross 3, you definitely will find, but this needs some time to calculate. So you will be bored if I take some higher order and so go on calculating, so you will miss that means the connectivity with the class. So I am avoiding to show you much of the calculation here, rather I am concentrating on the concept basically. So I just shown you by any order of 2 order 2 will satisfy all three. So definitely for any other order also, definitely. So you can try at home, you have enough of time, you can practice at home, and if in case you feel problem with any of the example you have chosen, you just come back to me. I will show it by taking time and explain how it is satisfying the rules. Okay, so this will be the end of this episode. In the next episode I will also show you some of the rules, you can say the rule or the restrictions where you cannot perform the matrix operation, and this is true for any order of the matrix. So that I will definitely show you in my next episode. So thank you for now.